start this next week. So a few notes about this week is that we're going to be mixing in more advanced topics in web development and also sponsor lectures. So today is the first example of a sponsor lecture. We have Andy here from Oracle, and he's going to talk a little bit about something important to him, and hopefully important to all of you, because you're going to be needing it. So it's going to be the document object model. So without further ado,
all right, thanks, Aaron.
go for it.
Volume level okay?
Yeah.
Okay, cool. I'm Andy, as Aaron mentioned, from Oracle. And Aaron mentioned that you guys have had some exposure to the document object model already. So what I hope to do today is give you a little bit more context and some history and maybe a little more detail than your past introduction. I did want to tell you a little bit about myself before we get started. So I do not attend MIT like all of you guys, but I have attended several swim meets and swim team practices at the Z Center over the last couple of years. My 9-year-old son Toby is a competitive swimmer. So he is like super impressed that his dad is speaking to kids at the school where he sometimes goes to swim. And also, the last swim meet, he left his favorite pair of shoes at the Z Center. So if you guys see a size 2 pair of Vans, he wore his flip-flop home. And anyway, so I joined Oracle out of college many years ago. I'm not going to say exactly how many years, although it will be revealed during the course of this presentation. And at Oracle, the primary thing I've been working on is user interface technology. So today, what that means is front-end development. Web application development. But at a big company like Oracle, there's so many teams doing product development, building web UIs. It's very important to have a consistent user experience across those products. So at Oracle, we have, like all big companies, we have a user experience team that specifies a design standard. And in addition to the designs, we have a centralized team that is actually building the componentry, actually building up the UI components that implement that design. So that way we can achieve consistency across our products. So I don't work on the user experience team, I work on the team that builds the components that the user experience team specifies. So that's Oracle Jet is the name of our component framework and component set. And I'll tell you a little bit more about that at the end of the lecture. But one little technical detail I wanted to mention. So there's a link here where you can follow. I'll drive the slides, but you can follow along in your own browsers here. And anytime you see blue text, like the Oracle Jet, that's actually a hyperlink. So you can, if you get, if you lose interest, you can click on those and drill into whatever's there. With that, I was thinking about how to start, and so we're all aspiring front-end developers in this class, and I thought I can start. I did a lot of research, and I came up with this list of like the top 3 technologies you guys need to know. So I spent a long time on this part. So number 1, HTML. Obviously, yeah. Okay, this list is I'm just being facetious. So HTML, CSS, of course. You want your web pages to look nice. You're going to learn cascading style sheets. And the lingua franca of the web, JavaScript, you're going to want to know how to code JavaScript. But after that, what's next? You learn a web framework. I don't know, do you learn some other part of the web stack? So as you maybe could guess from the subject of this talk, I think the number 4, you did a top 4 list, I would say DOM comes right after JavaScript, document object model. So this is the obligatory definitional slide. Every talk should have one of these. So what is a DOM? Well, if you think about the process by which a browser takes this textual file, this document with HTML content in it, and ends up presenting that to the end user in an interactive way, well, the textual representation of that document is not in an efficient way to represent the page if your goal is to actually lay out the contents of that and display it to the end user. So the browser goes through a process after it downloads a document, it's going to parse it, and it's going to get it into a tree-like structure to make it easy to traverse and to figure out what the content of the page is, how to do things like apply cascading style sheets, and figure out where everything goes on the page. It's going to lay out based on that tree structure. So the browser needs this tree structure for its own purposes, just to get to the point where it can display the contents of your page to the end user. But it turns out that it's actually handy for us web developers, to have access to that same tree structure. And so that structure is exposed through this document object model. So there's really sort of three things from this slide that are important. So one is it's a tree. We're going to come back to that theme later. The second thing is that this tree is mutable. So what that means is if you can get a reference to one of these objects and an element in the tree, you can modify it, and the browser is just hanging out waiting for you to do that. It detects that something's changed, and it figures out how to relay out and repaint the page so that the results are immediately displayed to the end user. And then the third thing is that this API is a standard. Document object model is a standard. So this is really important because without a standard, if every browser implementation said, well, we're going to do the document object model a little differently, it will make life miserable for all of us. At the very least, you're going to end up with brittle websites. Hopefully you'll test on every browser and maybe you find some discrepancy between, I don't know, one Chrome and Safari. But in all likelihood, your end users are going to be using some browser, some version that you haven't tested yet. And without a standard, you're kind of doomed to run into, to introduce bugs. It just makes life difficult. So I wanted to do a quick history of the document object model, but also incorporate some other important technologies. So 1993 was a momentous year. For two reasons. If it wasn't for things that happened in this year, we wouldn't be here today. The first thing was in May of 1993, I graduated from college. And then, shortly thereafter, in June of 1993, another game changer, the first public release of a web browser, the NCSA Mosaic browser. And so at that point, there was no JavaScript, there was no CSS. The purpose of the browser was serving up that document, and the main mechanism for interactivity was the hyperlink, right? So you can navigate from one page to another. But that's it, the content's fairly static. You're generating the web content on the server, you're not modifying it in the browser. But it didn't take long before the browser vendors realized that that web pages can become way more interactive with a little bit of sprinkling in a little bit of some magic sauce, which is JavaScript. So in the mythology of the JavaScript language, the common story is that Brendan Eich, a developer at Netscape, had 2 weeks to get some scripting language into the browser, at which point he quickly coded up JavaScript. It landed, I think it wasn't called JavaScript initially, but eventually this came to be the JavaScript that we all know and love. So in addition to JavaScript, with the initial release, so this was Netscape Navigator 2, and with the introduction of the scripting language, there was also a minimal, non-standard Netscape-specific DOM-like thing. So that DOM was not a tree structure. It was basically collections of well-known objects. So you could get to a list of all of the images on the page and do things like add rollover effects, or add a collection of all the input components on the page and use that to do client-side validation. But it wasn't the full-blown tree representation, and it certainly wasn't a standard. So it wasn't long before that caught the attention of Microsoft, and so they introduced JScript, a variant of JavaScript in Internet Explorer 3, and they also basically copied the sort of Netscape document object model. Sometimes the sort of early pre-standard version document object model is referred to as DOM level 0. It predates any specification. So at this point, so we had two browsers now that had some scripting language and some DOM-like thing, and they were fairly close together, and so you could kind of code once and it would run on Netscape, Navigator, and run on IE. But it didn't take long before things started to diverge. So two interesting things from 1997. So both Netscape and IE released new versions of their browsers with more elaborate DOM support, often referred to as dynamic HTML. So the problem at this point was, so when Microsoft initially introduced JScript in their DOM, they were just trying to kind of more or less copy what had been there in Netscape. But after 1996, Netscape and Microsoft decided, well, now it's a race to bring more power to our developers' hands, and so they developed new DOM-like APIs in parallel. And since that work was being done in parallel, things started to diverge. So this is where things kind of began to get painful. You have to do things one way in IE and a different way in Netscape. On a positive note, any divergence between JavaScript and JScript was kind of headed off. The ECMA standards organization released the first version of the ECMAScript specification, which is basically just a standard that the JavaScript you know today is based on. So that was a good move. And then finally in 1998, the W3C realized that having these divergent DOM APIs is not a recipe for success. So the first specification, the first standard for the document object model was released in 1998. So that's really good news. And those standard APIs continue to evolve with a couple of minor releases through the years. But by 2004, the rate at which the web specifications were being developed by the W3C it wasn't at the sort of pace that the browser vendors wanted to see. So a group, I think initially folks from Mozilla, Opera, and Apple for Safari formed this separate working group outside the W3C. It's the Web Hypertext Application Technology Working Group. And their goal was to really push forward to innovate, improve what you can do as a web developer in the browser, and help the standards evolve at a faster rate. So the efforts of this working group, and they were later joined by Microsoft and Google as well, so all the browser vendors participate in this organization, helped lead to the release of HTML5, which was a more fully featured version of HTML, and lots of improvements to the document object model as well. So I do want to mention, how many folks here have heard of jQuery? Okay, great. So 2006, so we've already had, it's been 8 years since DOM level 1, since the DOM was standardized. And this new little framework, jQuery, arrived and kind of took the web development world by storm. And so what jQuery did was it put a little facade on top of the DOM that made it easier to do things like select elements out of the document and then modify them in various ways, like manipulating style classes, adding event listeners. So at a certain point, like every popular website used jQuery. I think even today, if you look at like jQuery usage in the top 1,000 websites, it's huge, it's like 60 or 70%. So like one question is, if we had standards we had like this DOM level 1 standard back in 1998, and like I said, like standards are so important, you could write once and run on any browser. Why do we need jQuery like so many years later? So a couple of problems. So one is that even in 2006, web developers were stuck supporting browsers from way back in, before these standards emerged. So you need some layer to provide cross-browser compatibility for that, and jQuery really addressed that. The other issue is that even though we see that there's been progress with DOM level 2, DOM level 3 releases, it takes time for the browser vendors to get those out into production. And so there's this lag, right? So there's a situation where, hey, there's this great new standard API, I want to start using it, but okay, it's not there in this browser, and I still have to support this old version of the browser. So jQuery is a big benefit, help you avoid having to think about those different browser combinations. Now, over the years, what's happened is the DOM specs continue to evolve with the support of this WELT working group. In 2015, W3C standardized on a particular slice of the WELT working group's efforts, and so we have DOM level 4. And one of the features of DOM level 4, as I think we'll see a little bit, is that it incorporates it borrows some inspiration from jQuery. So you're needing to use jQuery less and less. And then finally today, the WELT working group continues to evolve the DOM standards, and they have what they call a living standard. So basically all the browser vendors agree to some functionality, some API. When there is consensus, it gets added into this living standard, and the W3C expects the recommendations effectively follow the WELT working group living standard. Okay, so this is the part where I convince you that you need to learn DOM, although hopefully you already agree that but like if you're learning a web framework like React, honest question is like, do I really need to know these low-level DOM APIs? So React, like many other web frameworks, defines an abstraction over the document object model API. What that means is when you're building a React application, when you're writing a render function, when you're using JSX, using virtual DOM, you're not coding directly against the browser DOM APIs, you're coding against its virtual DOM mechanism. So React is kind of hiding some of the details of the lower level DOM APIs from you, which is great. So, so in theory, you don't need to know any of this stuff, but in practice, I'm citing one of my favorite software developer bloggers, Joel Spolsky, who coined this law of leaky abstractions. So abstractions have leaks, right? There's always cases where the underlying layers will bleed through. So in the case of React, I don't think it's something you guys would have covered yet, but there's a mechanism called ref, as in like references. So in your React components, there's a mechanism for getting a reference to an underlying DOM node, like actual DOM node, not a virtual DOM node. And it's not a common thing to have to do. The React documentation gives a few examples where this comes up. Like for example, if you need to programmatically set the focus to a particular DOM node in the browser, well, you can't do that in a render function. You're just producing virtual DOM. But you can get a reference to the actual live DOM node and call the focus method on it. And anyway, I recommend reading this article, which is linked, one of Joel's old blogs. Okay, and then another reason why it's worth learning the DOM APIs. So yes, we all delegate to tools like React or frameworks like React and others as well. But actually understanding how those are implemented will make you better users of those tools. So if you understand the underlying mechanics of React, I mean, maybe you don't need to for this class, but as future web developers, believe me, there's going to be a day if you're doing front-end development where something's not working the way you think it should work. And having an understanding of how the tool you're using is implemented will make you more self-sufficient. So like you won't be stuck just like posting a question to Stack Overflow, which by the way was co-founded by Joel Spolsky, who I just referenced. Instead, you'll be able to dig into it and kind of find the answer for yourself. So that's good. And then this is my funny reason, which is if you spend time in the web development world, one thing you'll see is that there are new web frameworks released about once a week. So there are many web frameworks, and if all of you, I don't know how many people are here today, but my guess is if you all go into like web development in the future, someday at least like 3 to 5 of you will implement your own web framework. And when you do, I want you to remember this slide, and also send me, like get in touch with me and tell me, because I would like to check it out and see what you guys come up with. But even if you're not going to implement your own web framework, as a user, let's say you're just going to use React for all your projects for the next 10 years, that's fine. But all these frameworks are open source, and you may want to contribute. It may be as simple as submitting an issue when you encounter a bug. Well, you want to be thoughtful about how you do that, and if you don't understand how things are working, you're not going to be able to do that. And then finally, while we're all big fans of web frameworks, there's also a school of thought, there are trade-offs, right, with everything. So there's a school of thought that in some cases, pulling in a web framework like React or others can be overkill. So there may be some types of projects, some types of applications where it's like, it's speed, performance, the footprint is super important. I don't know, you may be targeting like mobile users who are on very poor networks and don't have powerful, phones. So in some cases, you may say, like, for this project, I'm not using any web framework. I'm just going to code directly against the APIs that come with the browser, which means DOM. Okay, so hopefully by now, you guys are all on board that learning DOM is important. So where do we start with learning DOM? Well, mentioned before, important aspect of DOM is that it's this tree. What is it a tree of? What's in the tree? Well, everything in the DOM tree is a node. This just links up to the NPM documentation for the node interface. So, and by the way, I included links to the NPM documentation. So you kind of have two choices for how to learn more about these things. Well, there's lots of choices, but two types of documentation. So one thing you can do is you can actually go look at the DOM specification and read all the hairy details. But the specifications, for the most part, are really targeting browser implementers and not so much web developers. There will be times where you want to go look at the specification. But for the most part, the Mozilla Developer Network has fantastic documentation for all web APIs, including the DOM. So I've been linking to that. I recommend checking it out. So everything in the DOM tree, every object in the DOM tree implements this interface node, which basically is a structural interface, as we'll see. And there's a hierarchy of types of objects in the DOM tree. So everything is a node, but there's a subtype element. So all the HTML elements in your document will be reflected in the DOM tree via this element type. So the difference between an element and a node, so element is a type of node, so it has all the properties and methods that you find on a node. But an element has other stuff that make it specific to being an element, such as having a tag name, right? So div, span, whatever. And also elements have attributes. Not all types of nodes have attributes. So for any element that you see in your HTML document, there is going to be this node of type element in the DOM tree. But just to give you an example of another type of node that you might find, anything that's text. So if you have a div with hello world, and then close bracket div, that thing in the middle, that text, is represented in the DOM tree as well. And it doesn't have a tag name, doesn't have attributes, it's not an element, it's a text node. Similarly, there's nodes for comments, and a node for the document itself. And this one you might have already kind of seen in action. The browsers expose a global field, just a document field, and you can use it to do things like call document get element by ID. So document itself is a type of node. Again, that has more interesting APIs like get element by ID, more interesting than text, but it's not itself an element. And then finally, there's an extensive hierarchy under this. So under element, well, there's different types of elements in HTML documents. There may be SVG elements, so structured vector graphics. This is just a partial class hierarchy. I just took a few of the key interfaces and dumped them in here. So under HTML element, there's types specific to every type of HTML element under the sun. So I put a few examples here, button, div, input. They each have their own types with their own set of properties and methods specific to that type. But the important thing is that everything here is some type of a node. So another good starting point for if we're going to start trying to get at elements inside the document, inside this DOM tree, an easy place to start is just right off that document object. There's three very well-known elements that you can get at there. The document element itself, which is the opening HTML, the sort of root HTML element in your document. and then you can get at the element corresponding to the head, element corresponding to the body. But this is a tree structure, and I'm sure for folks who are CS students who've taken your first data structures class, in a tree, the first thing you want to figure out how to do is how to traverse it. And so in the DOM, of course, this is also possible. In the document object model, it kind of has a little bit of a dichotomy regarding how you get at nodes, depending on whether you're trying to get at all of the nodes, including text nodes and comment nodes and element nodes, or just the element nodes. So in this case, any DOM node that's a parent node is going to have two ways to get at the children: child nodes and children. So child nodes will return the full set of nodes, and children will just return the elements. So in this little example, the div is a parent node. It has 3 node children. Child nodes will return all 3 of them, and children will return just one, a collection of just one node, which is the span element. So typically, you're going to know which one of these you want to use. If you're just trying to get at elements, use the element form. Similarly, so the first 2 items will return a collection that contain all of the matching children, and then you can also just get directly at the first child. So in this case, it's very similar. The first child the first child property for this div will return the text node hello. The first element child property would be pointing to the span, the 3rd node child, but the first element child. And then there's also pointers to the last child and last element child as well. And then, not to limit things in any way, in addition to going down from parent to child, you can go sideways to your next sibling, previous sibling, and the same sort of rules apply here. So like next sibling will get you the next node regardless of the type. Next element sibling will just go directly to the next node that's an actual element. And then finally, you can also, in addition to walking down, sideways, you can also traverse back up, and you can do this as well in a node-centric way or an element-centric way. And so this can be kind of useful if the content that you're dealing with is sort of context dependent. So if it needs to behave one way, depending on whether it's embedded in one area of your page versus another area, you can walk up and kind of see, well, where am I? And then one thing I wanted to mention was that every node has an owner document. We'll see later that there's an API document create element, which you use to create all your elements. There's other these factory methods for creating other types of nodes, but you're always creating nodes off of some document. So even if that node or that element has not yet been actually physically added into the document, it has an associated document with it, like the owning document that you used to create that node. So I just wanted to call that out. So in this case, the only case where there's a difference between parent node and parent element is when you get up to the HTML element. So at that point, the HTML element does have a parent node that's document, but it does not have a parent element because the document node is not an element. Okay, so now we can all write these traversal algorithms. And I should say, I hate to say this, but I'm really only scratching the surface of these DOM APIs. These are the most basic ones. If you go look at the MDN documentation, you'll see there's all sorts of other APIs. So I'm just focusing on sort of the really core ones that are used a lot. So I'm sure you guys don't want to be writing tree traversal code just to find some button in the middle of your web page. So like we talked about, there's other ways to do this. Get element by ID is one you've probably seen before. Any element can have an ID associated with it, a unique identifier. So if you know that identifier, you can just, with one call, go and grab it in a very efficient way. And then there's a couple of other approaches. So get elements by class name. If you want to get all the buttons in your page, let's get elements by tag name. If you want to get all the buttons or all the spans in your page, you can call this, pass in the tag name that you're trying to, the elements that you're trying to retrieve. For class name, that's just a style class, so you can retrieve all the elements that have some class set on it, which is handy. So So I think you guys have looked at CSS, and one interesting thing is that CSS has a very similar problem in terms of having this requirement to be able to specify specific targets within the DOM tree. So in CSS, there's a selector mechanism that will let you say, I want this style rule to apply to a specific element with this ID, or to all the elements with this class, or variations of that. There's, you could say, well, in this case, I gave an example of a compound selector. So give me all the divs that have the class pick me. So I think that's div number 2. And then there's also structural combinators that allow you to pick children of a particular type of element. So this is a way more powerful mechanism for selecting elements from the DOM than get element by ID or get elements by tag name. These CSS selectors can be arbitrarily complex. Yeah, it would be great if we could use similar kind of selector mechanism with the DOM APIs. And this is actually an area where jQuery really shined, because it effectively let you use CSS style selectors to get at, to select elements that jQuery would then operate on. But the DOM, for a long time, didn't have any equivalent of that. So I think it's as of DOM 4, the most recent edition, there is Query Selector, which basically takes the same kind of CSS style selector that hopefully you're familiar with, and will match the first element, will return the first element matching that, or Query Selector All will return a collection of all the elements that match your selector. You can actually pass in multiple selectors and it will return a union of all of these. So this is a super powerful way to get at contents in your DOM. And when you all start your web development jobs, you're going to impress your coworkers by using this instead of get elements by tag name. Yeah?
Why is this better than get elements by tag name or get elements by...
Yeah, so get elements by tag name is limited. The only thing you can specify is just the tag name. So with Query Selector and Query Selector All, you can actually use these like sort of combination selectors. So for example, you can pass like div.pickme, and instead of just picking all the divs or all the elements with pickme, it'll find all the elements that actually match up. So all the divs with the class pickme, or similarly like a structural one. So if you wanted to say, I want to get all the elements with the style class pickme that happen to be a direct child of a div, then you could use this like combinator kind of approach, and that would end up, in this example, it would end up picking the span, but it wouldn't pick the div up above number 2 that also has the same class. So it's just very much more flexible than just saying like, give me all the elements with a particular tag name, or give me all the elements with a particular class. So yeah, definitely a great tool to have. Okay, so we spent a lot of time talking about how to find elements. So the next question is like, what do we do once we find the element? And well, like good front-end developers, we hack. So once you've got an element, you can get any attribute. You can interact with the attributes, including setting new values for attributes, removing attributes. So you're basically mucking with the HTML on the client after it's been processed by the browser. And then this is a little bit of a subtle point, and I think I'm going to jump into Chrome DevTools to illustrate it. But so elements have two ways to kind of represent the attributes of the element, or attributes or properties of the element. So one is, so there's this basically map of the attributes where you can call get attribute, pass name, and it returns a string value for that attribute. But DOM elements themselves are just JavaScript objects, and JavaScript objects have properties or fields of their own. And so what happens in the DOM is that the attributes that you specify in your HTML end up being exposed on the DOM elements as just plain old JavaScript properties. I'm gonna like break out of this momentarily and let's see if I can show you what that means. Let me see. Okay, So let's switch over to a React app. And I'm going to bring up Chrome DevTools. Hopefully this is what you guys see when you guys go into the app. Okay, the text is going to be big enough, but so let's find some buttons. Let's see how many buttons we have on this page. So I'm going to use, oh actually let me make the font a little bigger, sorry. Can folks see the, yeah, hopefully you can see it now. Okay, let's see if this. So I'm just using query selector all to fetch all of the buttons. This, maybe we can like take a look at the first item there, the first button there, 1 second. I might get it too big to be useful for me. Hold on a second. So we can grab like the first item out of this collection of buttons. And that, so it's actually highlighting it for me. Chrome DevTools is amazing, powerful. This is maybe number 5 on my list of technologies to learn. Become an expert at using Chrome DevTools. So we've got this button that corresponds to that login button. Let me stash it away. Oops. Oops. Let me stash it away in a properly named variable, just because it's going to be annoying. Okay, so I've got this button here. So at the moment, this doesn't have any, I'm going to play around with the tab index attribute, which is just a standard attribute that is exposed on all HTML elements. It affects the navigation order of the element. So it's actually a number type. So it's tab index 1 is going to be traversed before an element with tab index 2, but you can mess with this programmatically. So I'm going to just set the attribute to some value. And so when you're setting attributes, you typically use string values. So now that I've set that, it's available as a string value file. But so saying like this button object, so it's a DOM element, it's also a JavaScript object. So as a JavaScript object, it has a set of properties. And so this tab index property, by virtue of setting it as an attribute, it's reflected out as a property as well. So one thing that's interesting about this property is that the type of this property is actually a number. So we set the tab index as a string, it's reflected out as a number type property. One other thing that's interesting, and by the way, the sort of reflection and mirroring goes both ways. So if I can set the tab index property here to something else, and then I can go get the attribute. And if I typos, I can get it. So I get back the string number 1, so I set it to the number 1, get back the string number 1. So one important difference between attributes and properties, attributes are case insensitive, so I can, well, let's just get it. So I can get the attribute using any weird combination of uppercase and lowercase letters, but I can't do the same thing with properties. These JavaScript properties or fields on a JavaScript object are case sensitive, so you always have to use the proper casing. So I just thought it's important to kind of get familiar with the sort of fact that there's these 2 different ways in which your elements can be configured programmatically. One is through the attribute set, which is always string-based, and the other is through the properties on the DOM elements themselves, which is a more sort of type-safe way of doing it. Okay, let me see if I can get back to. Okay. So properties versus attributes, a little subtle thing, but worth talking about. So now that we've got access to the DOM elements, we can do other things like messing with styles. So the style attribute is just yet another attribute that we can hack on. But similar to the way that the tab index attribute is exposed as property. Your inline style attribute is also exposed through the style object, which is, again, like this type-specific API. I'm just going to quickly show that too. One sec. So we've got our button. We can set the style attribute. Sorry, set attribute, style. And so this just takes a CSS property. So like background color is a popular one. So I just set the style property. I included an inline style. And if I go look at the style object, so actually it's kind of interesting because the Chrome DevTools is showing me that this button.style property is of type CSS style declaration, and it has all sorts of sub-properties or fields on that. And one of them is background color, and I see that it's red. So one thing you might notice if you look closely, when I'm setting the attribute form, I specify background hyphen color, right? So there's this hyphen separator, the dash there, which is how it would show up inside of a CSS style sheet. But when I reference the property field off of the style object, I'm specifying there's no dash. It's just it's camel case, so lowercase background, uppercase C for color. And the reason for that is that in the second form, it's not quoted, it's not in a string. So it's just a JavaScript identifier, and the dash, of course, in JavaScript is actually a subtraction operator, so it can't be part of a field name. So instead the properties are reflected out using these camel case names. In any case, we sort of showed that once we've got access to an element, we can hack on the styles to our heart's content. On the style object, there's also the CSS text field, which is very similar to the style attribute. You can specify a string that includes CSS properties, and the browser will parse those and apply them to the document. Oh, and then one little bonus thing. We haven't talked about the window object. That's another global object. I kind of didn't mention it because I told you guys that everything is a node. Window isn't a node, but the window is not actually in the DOM tree, so it doesn't count. But yeah, so window is kind of the container for the document itself, the container for the DOM tree. And window has this interesting method on it called getComputedStyle, which instead of just getting the values of style properties that you specified locally on your element, this will actually tell you, after applying all the CSS rules, of which there may be many that apply to your element, what is the resolved value of those rules? So if the background color was specified inside of an external CSS style sheet through some rule, and you want to find out programmatically, well, what did it end up being in this particular element, you could use window getComputedStyle and pass in the element, and it will tell you the resolved value, so it's pretty powerful API. And then the other thing, in addition to specifying style properties directly on the elements, there's also a few mechanisms for specifying, for adding and removing classes. And the first, of course, is setting it as an attribute, the class attribute. And the second, I guess the second thing is just, the class name is just how the class attribute is reflected out to the properties as a JavaScript field. So a similar kind of problem here where, like I mentioned, like you can't use the sort of hyphen separator in a name. Well, the other thing you can't do is you can't use class, the name class as a field name, because class is a reserved keyword in JavaScript. So they reflect that out as class name. And then the class list is a more convenient way to add and remove classes. So both the class attribute and class name property are just a string, so which can contain multiple classes. So if you wanted to add a class or remove a class, you end up having to do string manipulation. You have to parse the string, split it, figure out, was that class there already before you add it? If so, I'm not going to add it. And so this is another area where jQuery made things really nice because it had APIs for just toggling classes, and you don't have to worry about what's there already. So this is another case where the DOM specs evolved to kind of match what was there with jQuery. So you can use class list in a similar fashion. So we can remove nodes, either remove child or remove a child node. We can call remove on an element to remove itself. And then we can add our own custom content, and this is a really common thing. So I think you guys probably seen document create element before. It takes the name of the element you want to create. There's other factory methods for things like creating text nodes. Once you've created your element, you can call an API like append child or insert before or replace child to actually connect it into the DOM, at which point it, the browser will relay out and show that fresh content. So this is a mechanism for dynamically creating content on the client without having to do a round trip to the server, without having to fetch a new HTML page. Typically what we would do is issue a REST request to get some data down, and now in response to having data, you need to show that to your end user. While you might iterate over your data and call document create element for each node, populate the DOM tree, add it in, and the browser will display it. Okay, and then one last thing we haven't talked about at all is responding to user interaction. So if you have a button, user clicks on it, you want some way to respond to that click. And so in the early days of DOM, there wasn't a standard mechanism for adding and removing event listeners. In DOM level 2, they standardized on this. For a long time, people were using IE-specific APIs for doing this and having to do sort of different approaches on different browsers. So the addition of these standard mechanisms for adding a listener and removing listeners is super handy. There's also a standard event object, and there's a whole class hierarchy under the event for different types of events, like mouse events, key events, UI events have sort of different properties and different fields on them. And so one thing that I wanted to mention was that there's an interesting life cycle for how events are delivered. So in this example of a little sort of chain of DOM elements, if we want to listen for clicks on this button, we can call add event listener, specify the click type, and pass in a function that will get called back. That function is going to get called back with an event object using the standard event API. But the event delivery lifecycle is more interesting. So there's events propagate both down and back up the DOM tree. So there's 3 phases during event delivery. There's a capture phase. So before the event is delivered, before that click event is delivered to the button, it's actually delivered to every node above the button, starting from the document and then descending down, in this case, to the HTML element body div. And that's during the capture phase. Then when it reaches the event target, in this case the button, the event will be delivered to the button element, to any listeners registered on the button element. And then afterwards, there's a bubble phase where the event bubbles back up and any listeners on any ancestors will be invoked as well. So it seems a little weird, but so the idea here is that, so for the capture phase, depending on the type of application you're implementing, you may have reasons for wanting to know about user interaction before the content that's embedded in you responds to that user interaction. So it's kind of an edge case, but it might be like if you're implementing a design tool that has like a canvas and you're laying out content in the browser, when you click on the button, your design tool might want to take that as an indication that that button should be highlighted and selected. And you bring up a property editor that lets you edit the properties of that button. So what you would do in that sort of situation is you would add your capture listener higher up in the hierarchy, somewhere up above the button, like at the root of your sort of design canvas. And when you call add event listener, there's the third argument to add event listener. So after the event type and the function, there's third argument which lets you specify whether or not you want to receive the events during the capture phase. In which case, you register your event listener up above, you'll get called back before even the button sees that event. And then the bubble phase, you don't have to specify a special flag. If we just added the event click listener to the div or the body, those events are going to propagate up, and eventually will be the event listener for the body will be notified, hey, there's a button underneath you was clicked. There's a way to disrupt this flow of the events, which is a stop propagation method on the event object. Okay, so we spent a lot of time talking about DOM APIs. I wanted to tie it back to what you guys are doing in this class, which is learning React. So everything that we talked about today is useful if someday you want to implement your own virtual DOM engine, or at least understand how like React virtual DOM engine works. So in the, if you take an example, say you have a render function that's rendering comments from your blog, I think is an example that you guys have maybe looked at. So in your render function, you're producing a virtual DOM tree that represents whatever those list of comments. Maybe initially you just have one comment, so there's one virtual DOM node corresponding to that. You're not calling any of the APIs that we talked about before. You just got a little bit of JSX in your render function, and then you hand that off to React. And then what does React do? It goes and calls this. It's going to call document create element. It's going to call document append child. So easy enough. It's almost so easy that you probably could have just coded that yourself. But where the virtual DOM engine, the virtual DOM strategy really kind of shines is on subsequent updates. So if now you update your state and now you have 2 comments, well, if you weren't using virtual DOM, what would you do? You'd have to go look at the document, see like, oh, where should I add this in? Manually, programmatically go and create the content and add it in yourself. When you're using virtual DOM, what do? You just say, oh, well, I have this state, I have these properties. I'm going to invoke the same exact render function that was invoked the first time around, and spit out the projection of that content. So you're going to spit out a new virtual DOM tree. You don't have to worry about figuring out how you reconcile that with the live DOM. That's React's job. So second time through, now React has this old virtual DOM tree that has 1 comment node and a new one that has 2. It's basically going to walk over those and say, okay, is this first virtual DOM node the same as the second one? Yeah. So I don't have to do any work. I'm done with that one. We go on to the next one. Oh wait, so in the old tree there's only 1, in the new tree there's 2 comment nodes. So at that point, React's going to realize it has to call document create element. It's going to look at the properties on your virtual DOM node and, like, for example, call set attribute to configure that newly created element, DOM element, and add it into the tree. So that's just sort of the tip of the iceberg, but like you've seen a number of the APIs that like React would use under the covers. And then on a slight tangent, another thing that we can do using DOM APIs is we can create our own types of elements. So earlier in that class hierarchy I showed, there's an HTML element that has button, div, span. Well, so there's elements for every type of HTML element underneath there in the full class hierarchy, but we can add our own, which is really cool. So, so for example, in HTML, there's a table element, which basically displays sort of static tabular text. But in a modern web application, you may want, your table may have additional functionality like the ability to sort by clicking on a column header, drag and drop reordering columns, resizing columns. There's no HTML table element that does all that. You need to build it yourself. If you're building it in React, well, you can build a React component. There's lower level DOM APIs for creating your own custom element that extends that HTML element base class. And once you've created that class and registered it with the browser, that is just like any other, it behaves like any other HTML element. You can even use it in your document that you pulled down from the server. You can set attributes on it, you can get properties off of it, add it, remove it, hack on style classes. So all the things that we did, you can do with your own custom elements. And so the reason why I want to mention this is because I want to tie it back. This is what I actually work on. So the project that I work on is Oracle Jet. We build user interface components on top of this web component standards. It's part of the DOM. There's a link here if you want to kind of see more about the standards. One of the nice things about this web components approach is that it's totally framework agnostic. So your web component can be integrated into whatever your favorite web framework, whether it's React or Vue or Angular or Ember or something else. With all these, your web components are portable. You implement it once and you can use it anywhere. So that's a big win for us. All right, guys, it's noon. So if I accomplished anything, I hope you guys piqued your interest in DOM. It's an important thing to know. And one last minute, I have my shameless plug. So forgive me or humor me. So like Oracle has a great summer internship program. I don't know if you guys are already thinking, I know it's like middle of January, so maybe you're not thinking about summer quite yet. But if you are, there's a link here to get to the page. And in particular, if you are interested in this topic, if you're enjoying your web lab course, you might be interested in coming work on my team. We have positions in Burlington, so if you're staying local. If, on the other hand, you think this is kind of a waste of time and you're not so sure about all this web stuff, there's plenty of other opportunities too. There's positions at Oracle headquarters in different sites around the country. There's really good perks. And you would be embedded in an actual software development team, so you'd be, it's not like you're off with just like a group of other interns. You just work at your, just working directly with some team. So thank you guys so much. That's all I've got. Hope that was helpful.